Today we're going to learn how to evaluate limits of piecewise functions, and we're going to do it graphically and we're also going to do it algebraically. So we're going to be kind of getting in the direction of just doing it algebraically and not graphically because you're not always going to have a picture. But so for this page, you're on page, I'm assuming, I think it's page 9 in your packet, but it's number 9. And we're going to be, like I said, weaning into just strictly doing it algebraically. Please make sure you are taking notes in your packet. Okay, so if you look at this question, it's saying, let's look at the limit of the function as x approaches 3 from the negative direction. Now this function is graphed down here, and we're approaching 3, so here's x equals 3. From the negative direction would be this left-hand side. And then you can follow this over and you can see that that y value is -6. So we know the answer is -6. But again, you're not always going to have a picture. So when we have a piecewise function, what you're going to do is you're going to say, okay, we know that they want us to look at the limit as x approaches 3 from the negative direction. So what you do is you look at these two domains and you ask yourself, what numbers are approaching 3 but from the negative direction? So in other words, numbers less than 3, which would be this top part of the piecewise function. Okay, so when that happens, simply what you're going to do is you're going to plug in the 3, and the reason why we're plugging in 3 is because of this number 3 right here. It's also the 3 in both parts of that domain. And we're going to just plug in the 3 wherever we see an x. So I have a negative, and now I see an x, so I'm going to plug in 3. Then minus 3. And if you work that out, that's -6, which matches the picture. Okay, so this is algebraically, and this is graphically. Okay, make sure you're writing this down. Okay, if we look at number 10 and we do it graphically, same number as x approaches 3 from the negative direction. So here is 3 from the negative direction. So you can see that the final answer is 3. Okay, now we don't have a piecewise function here. We kind of, well, let me rephrase that. We do have a piecewise function, but the look of this is not like number 9 where we have the curly brackets and the two different domains. So what I would probably start by doing is, like I did on the last one, I'm going to plug in 3 in for both my x values. Okay, and let's see what I end up with. Okay, so when I plug in 3 in the numerator, I have 3, an absolute value, then negative, and then I have the x value, which is 3, plus 3, over negative, and then the x value, which is 3, plus 3. Well, if you work this all out, we've got 0 over 0. Okay, that's kind of problematic. That's called an indeterminate. It's not undefined, because undefined is just 0 in the denominator. We have 0 in the numerator and the denominator. So when that happens with a question like this, probably your best bet is to pick a number that's to the left of 3, like 2 or 1, or, you know, something like that. I like to try to pick a number pretty close to 3, so I would pick 2, okay? And let's see what happens when we plug that in. Okay, so I'm going to plug it into here. So I'm going to do 3. Now I'm picking 2, so that's going to be -2 plus 3 over -2 plus 3. And when we work that out, that's 3 over 1, which is 3. Okay, which backs up what I've got right here. So this limit right here is equal to 3. So let me just rewrite that. So the limit of the function as x approaches 3 from the negative direction would be 3. Make sure you're taking notes. Let's look at 11. Now 11 is interesting because there is no coming from the left or coming from the right. In this case, remember, if there's no number to the left or to the right as like an exponent, so to speak, in the original, that means you have to look from the left and from the right. Well, that's pretty easy. We can see if I look from the left, this is approaching -1. But if I come from the right, I'm approaching, I can't even read that, my eyes are so bad, -2, -4, -5, right? I believe this is -5. So wouldn't this be a DNE? Now, if you're going to do it algebraically, what you're going to do is you're going to plug in that -2 into both the top and the part of the piecewise function, everywhere you see an x. Now, unfortunately, if we look here, there is no x. So actually, that makes our life pretty easy. We're just going to write -1. Okay, and if you look at that, that's exactly what we have here. Okay, all right, now I'm going to plug in -2 into the bottom part of the piecewise function. So I've got -2 times the -2 minus 9. And when I work that out, that's -5. Okay, and that makes sense because look, this is approaching -5. And then you can see, not graphically but algebraically, these two answers don't match. If those two answers don't match, then the limit of the function as x approaches, in this case, -2, would just be a DNE. The only way it can actually work, and we would actually get a numerical answer, is if both of these numbers were the same. Okay? All right, let's look at 12. Now, again here, there's no number after this, so they want us to look at the graph as x approaches 2 from the negative direction and from the positive direction. And you can see that they're actually approaching the same y value, which is -3. Okay, so that's how we would do it graphically. Let's do it algebraically. So we're going to, like the last one, you're going to plug it into both the top part of the piecewise function and the bottom part of the piecewise function. We're going to plug in 2. So I've got negative, and then I've got 2/2 minus 2. So -2/2 is -1, minus 2 is -3. And then down here, I'm going to do negative, and that's going to be 2 squared plus 1. Okay, so remember, 2 squared is 4, but we're negating it. And then when we add 1, we're going to get -3. So now you can see that both of these guys are the same. That's great. So then our limit of the function as x approaches 2 would be the answer that we got, which is -3. Okay, when I say the answer that we got, I mean these two numbers right here. Okay, make sure that you're taking notes on this. Number 13. Now, look carefully because the number that the sign that comes after the number is back. So that means we're just looking at as x approaches -1 from the negative direction. So numbers that are less than -1. So numbers that are less than -1 would be this part of the piecewise function right here. Now, we could graph this. It's optional. Notice they didn't give us the graph now, so we're weaning off that graph and just going strictly algebraic. So again, because I'm coming from the left-hand side, these are numbers less than -1. I'm going to plug in -1 into here, and only there. All right, so here I go. So I've got a negative, and then x is a -1, and then -3. So obviously a -1 is a +1, -3 is -2. And that's your answer. So your limit of the function as x approaches -1 from the negative direction would be -2. So if you were graphing this, you would see that it's approaching a y value of -2. Okay, but now we just don't have to do the graph because they're not always going to give it to you, and it's kind of annoying to graph. All right, let's look at this question. So number 14, same deal. This time we're going to be going from the left and from the right because there's no little plus or minus sign here, and we're plugging in -2. Okay, all right. So I'm going to plug in -2 in the top here. Please remember, though, this negative is separate. We don't square that. So negative, and then we have negative 2, and we're squaring that, minus 4, oops, that's supposed to be minus, times negative 2 minus 5. Okay, and then this is just going to stay negative 1. All right, so let's work this guy out up here. So negative 2 squared is 4, but that's going to end up getting negated. Then we've got plus 8 minus 5. And you can see that that will be a negative 1. So it turns out that these guys are the same. Sorry about that. So the limit of the function as x approaches negative 2 is going to be negative 1. And there's your answer. Make sure you're taking notes.